there's honestly, it's preference, but when you're doing this in math class, converting between it is very rare when you absolutely need to. And honestly, I made you go from degrees to radians because that just in, like school wise, okay, not necessarily life, but in school wise, that is the most common thing you have to do. You're given information where your angle's written in degrees, but you're using a formula that's for radians only. Okay, so we're not going to be doing, as you can see from the assignment, you're not going to be doing a whole bunch. We're going to do the exact same thing we did the other day. We care about the positioning. So what we're trying to do is figure out where does our angle sit. And ultimately on the test, when I ask you the questions, instead of asking you for the sketch is your scratch work. In the end, we're going to go, where's that angle? Quadrant 1, 2, 3, or 4. Okay, so that'll be how the question is asked to you. And then we will find reference angles. Now, the first thing I always get kids going, oh, fractions. I'm not good at fractions, right? And then all they see is fractions. So they think this is going to be harder. I find it easier. And I know I'm a math teacher, but hopefully after I explain all this, you guys will be fine and you will prefer radians to degrees. So I'm going to start with something that on your table in front of you, draw a nice little rectangle. You did this when you were learning about fractions in elementary school. I would like you to draw as many lines as needed to break your rectangle up into 6 equally sized pieces. He wanted more than 6. Now he wants less than 6. Now he wants more than 6. It is very interesting for me to see how your brains work and how you came up with the answer to this question. And it's actually interesting for you guys to see it. You're over here at like every table. When somebody draws something different, you're kind of looking at them like, what are you doing? And the irony is, within a table, I'm seeing like, okay, one person started it one way and then everybody did it the same way because they looked at the other kids. But what's funny is, like, as I go from table to table, I don't always see the same thing. Like, this table's drawings are different than this table's drawings. I don't really care how you do it. How many pieces do I have right now? 2. How many do I have now? 6, which is what I wanted. Was there other ways to do it? Yeah. Some of you just tried to do all vertical lines, right? Some of you are trying to do angled things, like try to put some diagonals in there. And then right away, that's what some of the discussions I was hearing, like, oh, the pieces aren't the same size then, necessarily, depending on how you draw that. And that was the goal, to make them equally sized pieces, okay? This is how you're taught about fractions in elementary school, okay? It's like the first idea. So if I were to shade part of it, I might ask the question, what fraction of the rectangle is shaded? 2 out of the 6 pieces. So you start to go, okay, I have so many pieces and 2 of them are shaded. So you understand I'm going to do part out of the whole. Definition of a fraction. Okay, so what we're going to do with our angles is the same idea. If you can do that with a shape like a rectangle or a circle, you can do it with your Cartesian coordinate system. Okay, so we're just going to pick an angle. My angle that I'm going to work with is going to be, I want to keep it, we'll just say 1 pi over 6. Now I'm just writing the 1 for an emphasis, okay? So the pi is always attached. I want you to focus on the fractional part. What I'm going to do is I want you to read the problem or look at it this way. I want 1/6 of pi. In other words, I'm going to break pi into 6 pieces. On this picture, where's pi? Okay, over here, the negative x-axis, right? So from 0 to here is a half of a circle, right? It's like a semicircle. And I'm going to take that semicircle. So you don't need to draw this part, but I want you to think of it this way. I'm now going to break this into 6 equally sized pieces. Where do I put the lines? Try it on the table in front of you. Where would the lines go? It's helpful if you draw your axes in one color and then pass the marker to the next person so you have a different color to draw the lines, to make them stick out. Where will the lines go? So you have 6 equally sized pieces in that semicircle. Nice. Good job. Yeah, he's got it going on too. It's not 6 lines, it's 6 pieces. Oh, is it working? It was like, I know, from one side. I could see it. You're like drawing them in. I'm like, his lines aren't coming in. All right, it looks great as I'm going around the room. A lot of people have figured it out. Okay, so think about how I did this one. The first line I drew was halfway, right? I cut it into 2 pieces. Well, I'm being nice right now. I chose a denominator that was even. So by doing that, doesn't this line automatically get it into 2 pieces? Okay, now each of those pieces has to look identical as I break them up.